Hi everyone, I'm Jakub, founder and CEO of Deepnote. I have spent the better part of the last almost 10 years working on tools either for software engineering teams or data teams. And if there was one message I would share with the data world, then it's this one. Let your data team choose their own tools. In the next 10 minutes, we will talk about the tooling for software engineers. We'll talk about tooling for data practitioners. And we'll also talk about why the future for both is bright. Very quick introduction. I'm Jakub, and these topics are very close to my heart. I have been studying developer tooling. I have been building tooling for millions of developers, and I have been leading data teams, all of which led me to thinking about notebooks and building Deepnote. So what's Deepnote? Very quickly, well, we like to think of it as a notebook with magical powers, essentially a new kind of computational medium. And today, I would like to share what we learned while building Deepnote. So, first, most of us are already familiar with software engineering best practices, which have been studied in detail for decades. And many of us are probably even using these tools built for software engineers almost on a daily basis. And it makes sense. Developers like to build tools for developers. And some of the most complex pieces of software that have been ever created were created with a simple purpose: to scratch our own itch. Quick glance through GitHub tells a story how much effort goes into this, all of which is very good news for us, because thanks to all this effort, today, we have access to some really good tooling. And it's not just tools, it's actually the entire ecosystem. As software engineers, we have a chance to work within a very mature ecosystem. And within this ecosystem, we actually know pretty well how we can take a mock-up through a prototype all the way to the production. We have our favorite code editors and IDEs, so we know where to write code. We have agile methodologies, code conventions, design patterns, all of which tell us how to write code. We also have a suite of tools that help us write tests, and also another suite of tools to help us with continuous integration. We agreed on Git as a standard for versioning, and also have a few standard places where we collaborate, such as GitHub or GitLab. We have deployment models, we have infrastructure providers that are more than happy to host our applications, and we also know pretty well how to monitor those applications once they are in production. But while this ecosystem works great for building software, it doesn't really translate that well into data teams. Turns out data teams actually adopted these concepts and this ecosystem because software engineering world have always felt slightly more mature, slightly more ahead. And exactly as we already discussed, it makes sense. Developers build the tools for themselves first. And that's why historically, data teams have always had to rely on tools from software engineering world. Normally, this would be amazing. At the end of the day, we are standing on the shoulders of giants, but it has one big downside. We haven't just adopted the tools. We also adapted the same mental models. We also adapted the same workflows, and we also adapted the same principles. But the data teams don't always have the same goals as software engineering teams. The goal isn't always to ship a working product. Most of the time, data practitioners actually work around insights. Rather than a clickable dashboard, their goal is the understanding of the underlying problem. Sometimes the result is in a form of a dashboard or a simple data app. But if you look at the number of abandoned projects and reports, you'll quickly realize that majority of data projects come to an end the moment the insight is extracted. So the output of this kind of work isn't really an app. It is an insight. Sometimes in a well-documented PDF, sometimes in a PowerPoint presentation, but more often than not as a screenshot sent, maybe just simply through Slack. There might not even be an output at all, maybe just an improved understanding of the underlying problem. And as a result, all of this means that extracting insights is a messy process. There is no engineering workflow that we can rely on. It really is just trial and error. It's a SQL query after SQL query, visualization after visualization, every time digging deeper and deeper until we find the answer we were looking for. For this kind of work, software engineering practices, as we know them, are too rigid. We can't really work in the traditional linear fashion towards a solution because, well, we don't know what the solution is in the first place. As a result, the exploratory code that we write is also messy. And most of the time, it actually doesn't even make sense to clean it up because it will most likely never be used again. The code is messy because data teams don't really optimize for the same things that software engineering teams optimize for. They don't optimize for code quality. They really optimize for time to insight. And for this kind of work, there is actually a better model how to think about it. We call it exploratory programming. The term exploratory programming was first popularized in a 1983 paper by Bo Scheel, who was a manager at Xerox AI Systems. And he struggled with applying these rigid software development life cycles, as we know them, to the experimental AI code that he was writing. The trouble was that something so experimental as an AI system could not really be specified upfront. In that paper, he talks about how no amount of interrogation of the client or paper exercises will answer these questions. One just has to try some designs and see what works. When data teams receive a task, they don't really know what they are going to find out. They need to try and see what works. Software engineering and exploratory programming have lots in common, but we need to understand that they are fundamentally different. The tools that work well for one paradigm and one approach might simply not work that well for the other. And that's why we shouldn't force data teams to use the same tools as software teams. We should let data teams choose their own tools. If you ever want to chat about the future of tooling for data teams, it's really one of my most favorite topics. So feel free to reach out either over on Twitter or over email. Thank you everyone for watching.